First, the objectives of this experimental video are to examine the characteristic and operation of a TTL NOT gate and to simplify the output expression of NOT gates connected in series. While the equipment and materials that we're gonna need are 5 volts DC power supply, 1 piece of 74LS04 hex inverter gate, 1 piece of 5mm red LED, 1 piece of 1/2 watt 220 ohms resistor, and 1 piece of SPDT switch, 1 piece of breadboard, and some jumper wire. Here we have some introductory information about NOT gate, often called an inverter. It is a nice digital logic gate to start with because it has only a single input with simple behavior. If the input is true, then the output will be false. Similarly, a false input results in a true output. Here we can see a logic symbol for NOT gate. In the symbol, we can see a circle or a bubble, and that bubble is called the inverter. And also, we can see here the truth table for NOT gate. If the input is 0, then the output will be 1. If the input is 1, then the output will be 0. And also, we can see the hex inverter 7404, which is the pin configuration where 14 is the VCC and the 7 is the ground. So let's proceed to the procedure. The first one is to construct on the breadboard the NOT gate circuit shown in figure A. The figure A is a simple schematic diagram for NOT gate where 1 is the input and 2 is the output, and 7 is the ground and 14 is the VCC. Here we have our first procedure. Yes, we have the LED, red LED 55mm, and resistor 220 ohms, the IC 74LS04, and the SPDT switch. The pin configuration for 14, number 14 is the VCC, the number 7 is the ground, input is 1, and output is 2. The pin 1, we have the switch, and the pin 2, we have the resistor, and here in the resistor, we have the LED connection, and the negative polarity for the LED is connected to the ground. Let us test the circuit. Let's turn the power supply on for the 5 volts VCC. Here we have an IC with NOT gates. So the SPDT switch, if we have one input means 0 output. And if we have 0 output, we will have 1 input. And that is an IC with NOT gate. The third procedure is to construct on the breadboard the NOT gate circuit shown in figure B, which is the figure B. We're just gonna have another input and another output. You can see it in the schematic diagram. Let's follow that one. In the next procedure, we will use 2 inputs and 2 outputs. Our first input will be the pin number 1, the second input will be the pin number 3, the first output will be the pin number 2, and the second output will be the pin number 4. Since the NOT gate is an inverter, our output and input will now be equal or same. Let's turn the power supply on. Here, if we have 0 input, we will have 0 output. If we have 1 input, we will now have 1 output. The next procedure is to construct again in the breadboard the NOT gate circuit shown in the figure C. Here we have 3 inputs and 3 outputs. Then, observe and record in the truth table the output for each input. In our next procedure, we will use 3 inputs and 3 outputs. Our first input will be in the pin number 1, the second input will be in the pin number 3, the third input will be in the pin number 5. The first output will be in the pin number 2, the second output will be in the pin number 4, and the last output will be in the pin number 6. Since NOT gate is an inverter, our output and input will now be not the same. Since the first procedure was inverted and then the second procedure is now inverted again. Let's turn the power supply on. Here, see, if we have 1 output, we have 0 input. If we have 1 input, we will have 0 output. And that's it for our experimental video. We were able to achieve our objectives, which is examining the characteristics and the operation of a TTL NOT gate. and simplifying the output expression of the NOT gate in a series collection. Once again, I'm Marisa Inamara, and I hope that you learned something from this video. And thank you so much for watching. I hope to see you again. Bye-bye!